Hello everyone, I'm Adriel Aseniero, and I'm presenting Experiential Views towards human experience evaluation of design spaces using vision language models. I'd like to thank my co-authors from Autodesk Research, shown here, for their efforts in this project. Experiential Views is a proof of concept tool in which we explore the method of helping architects and designers predict how building occupants might experience their design spaces using vision language models or VLMs. Recent AI developments have opened opportunities for exploring new paradigms in design computing. An industry that we anticipate that can benefit from this disruption is architecture and building design. While some tools already provide simulations of the physical environment like lighting and airflow, there's still a lack of tools that help designers predict a more psychological or emotional response to a space. We believe that by leveraging a vision language model based on human-centric criteria, we can help them anticipate emotional responses to their designs to create better experiences for occupants. Hence, we fine-tuned a pre-trained VLM following this preliminary set of 3 human-centric dimensions: the social dimension, whether a scene looks social or isolating; the tranquil dimension, whether a scene looks tranquil or distracting; and inspirational dimension, whether a scene looks inspirational or boring. We used OpenAI's clip model and fine-tuned it with our own dataset of scenes composed of photos and 3D renders of an office space. We developed 2 methods of interacting with experiential views that evoke common CAD or BIM environments. First, a floor plan visualization and a web-based 3D viewer integration. The floor plan visualization shows the building floor plan with circles showing the evaluated scenes. You can view the details of each scene through a tooltip that contains the photo of the scene, its 3D rendered counterpart image, and bar graphs representing the scene's evaluated score for the 3 dimensions. We also display the scenes in a grid layout below the floor plan for easier browsing. The scenes can be sorted by selecting a dimension from the Sort menu. We also integrated experiential views to a WebGL-based 3D model viewer to enable a more dynamic evaluation of scenes. When the user clicks the Score View button, the current view gets evaluated by our fine-tuned model and displays the scores back to the viewer. Our vision is to use renderings to enable architects to evaluate their designs before the buildings get built. But since renderings may lack details like furniture and lighting, our idea is to use tools like Stable Diffusion to stylize renderings to get better scores. We also need to expand on our preliminary dimensions, most likely through a crowdsourcing effort to ensure diversity and reduce bias. And that brings me to the end of this talk. Thank you very much and hope to keep in touch.